We know according to Newton's law of gravitation, if there are two bodies of masses m1 and m2 separated by a distance r, there is a gravitational force between them, G m1 m2 by r square. This is the force applied by each body on the other body, but these two forces are not going to cancel because, as it is explained in the previous lecture, they are going to act on two different bodies. Now we would like to identify, say for example, the same two bodies are there, m1, m2, separated by the same distance. Now in between them, in between the two bodies in the same line, we want to add a third body m3 such that this new placed body shall experience a zero force, shall not experience any force. Let us see what are the forces acting on this m3 now. On m3, m1 applies a force of attraction. On m3, m1 applies a force of attraction. Let that value is something like F1. On m3, m2 also applies a force of attraction. Let that is equal to m2, F2. You might have noticed that gravitational force is always attractive. Therefore, on m3, both m1 and m2 are applying an attractive force. Therefore, these two forces are pulling the body m3 in opposite directions. We can write the value of the F1 and F2 using the Newton law of gravitation as, assuming this distance is x, if I assume the total distance as d, the remaining distance is d minus x. Now F1 between m1 and m3 is g m1 m3 by distance of separation between them is x. Similarly, we can write F2 as between the force between m3 and m2 as g m2 and m3 by the distance of the separation between them is d minus x whole square. But as per our condition taken, the resultant force acting on the point m3 has to become 0. If F resultant has to become 0, I would like to say F resultant on m3 is F1 minus F2. I have written F1 minus F2 because these two are acting in the opposite direction, shall be equated to 0. That implies the force 1 shall be equal to force 2. We know the values of force 1 and force 2. Let us just equate them. G m1 m3 by x square equal to G m2 m3 by d minus x whole square. So we can cancel these g's and m3's, and we can write the remaining equation as m1 by x square is equal to m2 by d minus x whole square. Therefore, d minus x by x whole square equal to m2 by m1. By taking the square root on both the sides, d minus x by x equal to square root of m2 by m1. By simplifying this equation that we have got further, by dividing with x, d by x minus 1 equal to square root of m2 by m1, d by x equal to square root of m2 by m1 plus 1. That implies x, where we are going to get a neutral point, where though you keep a body m3, it is not going to experience any force, is this much. That's the location of the point where the resultant force is going to be equal to 0. Therefore, the x is called as gravitationally a neutral point, such that whatever the mass that you keep at that point along the same line joining m1 and m2, it is not going to experience any force. and gravitational force is always attractive. This is all happening possible because of gravitational force is always attractive. Thank you for being with this, and let us continue this discussion in our further post. Thank you once again.